If you clicked on this video, it's because you want the following questions answered. Why do you need to know fractions? What is a fraction and what are its properties? We will answer these questions in this module, and over the course of 13 modules, you will learn everything there is to know about fractions. I encourage you to study each module in order and to master each one before you move on to the next. If you master these 13 modules, all higher level math will come easy and be open to you. The question is on the modules, what are they? In Module 1, this is the module that you're in right now, and it's answering those three questions. What is a fraction, and what are its properties? Adding and subtracting fractions will be discussed in Module 2. In Module 3, we will discuss multiplying and dividing fractions. Module 4, the law of signs and fractions. Module 5, compound fractions. Module 6, adding and subtracting compound fractions. Module 7, multiplying and dividing compound fractions. In Module 8, we'll look at proportions. In Module 9, we'll learn how to cancel fractions. In Module 10, we'll discuss the order of operation, PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction, and how they apply to fractions. In Module 11, we will discuss converting fractions to decimals and decimals to fractions. In Module 12, we will look at literal and numeric fractions. A literal fraction is a fraction that has letters in it, and numeric is numbers. And finally, in Module 13, fractions with equalities and inequalities. You need to know fractions because it is impossible to master algebra and other higher math without it. If you intend to enter the trades, you also need to know fractions. You cannot be proficient in any of the trades without knowing and using fractions. So then, what is a fraction and what are its properties? Any number that can be written in the form of A over B. That's how mathematicians state it. We will use, it really doesn't matter the letters that we use, we're going to use the letters N over D because it's more descriptive. For example, where N equals the numerator and D equals the denominator. N, numerator is on top, denominator on the bottom. Otherwise, you would have to remember that A is the numerator and B is the denominator, and they're not as descriptive as N over D. Generally, N and D are whole numbers, but they need not be. Here's some examples of fractions. 1/16, 1/8, 3/16, 1/4, 5/16, 3/8, 7/16, 1/2, 9/16, 5/8, 11/16, 3/4, 13/16, 7/8, 15/16, and finally 16/16. All these fractions are found on a ruler that's divided with 16 parts to the inch, or in 16ths of an inch increments. Here's an example of that ruler. If we count all these little places, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Here at this 2-inch mark, we would have 1 and 16/16, which is a whole number. 16 divided by 16 equals 1. Each one of these marks are a 16th of an inch, a 16th, an 1/8, 3/16, 4/16, which is a quarter, 5/16, 6/16, which is 3/8, 7/16, and 8/16 is a half. I think you're getting the point. Looking at it again, these minor marks, the shorter marks, are the ones that have 16 in them as a denominator. The next longest, shortest mark are the eighths, 1/8, 3/8, 5/8, 7/8. The quarters, 1/4, 3/4. Finally, the half is longer than those three, and the 1 inch is the longest yet. That's the whole number. That would be 16/16. Whole numbers can be written as a fraction also. For example, the whole numbers 1, 2, 3, 4, 5 can be written as a fraction. All we have to do is put them over 1. 1 over 1, 2 over 1, 3 over 1, 4 over 1, 5 over 1. If we divide any number by 1, that number stays the same. For example, 5 divided by 1 is still going to equal 1. Likewise, in multiplication, 1 times 1 is still 1, 1 times 2 is still 2, 1 times 3 is 3, 1 times 5 is 5. It does not change the value, but in this case it does put it into a fractional form, a over b or n over d. Denominators indicate how many parts equal the whole. Numerators indicate how many parts of the whole you have. For example, 1/2. 2 parts make the whole, but we have 1 out of 2 parts. Here, 4 parts make up the whole. We have 1 of those 4 parts. 1/8, 8 parts equal the whole. We have 1 part out of 8. And here, 1/16 equals 16 parts equal the whole. We have 1 part out of 16. Or we can say 1/16 of an inch, if this was a ruler. Whole numbers. This is a whole number here. If you notice, this ruler has 16 parts, 15/16. When I get to 16/16, that equals a whole number. For example, 16 divided by 16 would equal 1. We can look at fractions this way. This kind of describes it a little bit more. We have an 8-slice pizza over here and a 6-slice pizza over here. If I eat 3 slices of an 8-slice pie, I ate 3/8 of that pie. 8 is the parts that make up the whole. 1, 2, 3, 4, 5, 6, 7, 8. And 3 is the parts that I have, 3/8. Here, I have a 6-slice pie. 1, 2, 3, 4, 5, 6. If I eat 3 slices here, I have 3/6. 6 parts make up the whole. 3/6 is a half. Eating these 3 slices, I ate half the pie, and over here I only ate 3/8 of the pie because these slices are bigger. Fractions indicate division. In the case of that 8-slice pie, the 3/8 of the pie that we ate, we divide 8 into 3. 3 over 8, 8 divides into 3. 8 goes into 3 0 times. I bring up my decimal point and put a 0. 8 goes into 30 3 times. 3 times 8 is 24. We subtract that from 30. 24 from 30 is 6. 8 will not divide into 6, so we add another 0. 8 goes into 60 7 times. 7 times 8 equals 56. We subtract that from 60 and get 4. 8 will not divide into 4. We bring down another 0. 8 divides into 40 5 times. 5 times 8 is 40. We subtract it. 40 from 40 equals 0. There is no longer a remainder, so we are done dividing. This is what's called a terminating fraction. It terminates at 0.375 and no more. Fractions with numerators and denominators the same always equal the whole. For example, 2 divided by 2 equals 1. 4 divided by 4 equals 1. 8 divided by 8 equals 1. And 16 divided by 16 equals 1. Equivalent fractions have the same ratio. That is, when we divide the number, we get a decimal point. So if I divide 1 by 2, I get 0.5. If we divide 2 by 4, you will also get 0.5. If you divide 4 by 8, you will also get 0.5. 8 divided by 16 and 3 divided by 6 will all give you 0.5. That's our ratio, and the ratios are the same for all of them, therefore they are equivalent. We can make a fraction equivalent by multiplying it by a whole fraction. For example, I have 1/2 times 2. If I want to double this 1/2, I'm going to use a multiplier of 2, but I'm going to put it 2 over 2 because I'm not changing the value by making this 1. 1 times 2 is 2. 2 times 2 is 4. If I divide 2 by 4, I'm going to get 0.5. If I divide 1 by 2, I'm going to get 0.5. This 2/4, 2 over 4 right here, if I want to quadruple it, it's going to be, I'm going to multiply by 4, so 4 over 4 would be 2 times 4 equals 8. 4 times 4 equals 16. And now let's look at it. 1/2 equals 2/4. 1/2 equals 0.5. 2/4 equals 0.5. 4/8, if I want to divide numerator and denominators by the same values, let's say I want to reduce this fraction. So 4/8 divided by a whole number, 2. I want to cut it in half. These are even numbers, so they will be divisible by 2. Just to note, whenever you have a fraction, 4/8, 2/4, whatever it is, what you divide in must divide into each of these equally. 2 will go into 4 2 times. 2 divides into 8 4 times. So I reduce this fraction 4/8 to 2/4. 2/4, again, I want to divide it. 2 divided by 2 equals 1. 4 divided by 2 equals 2. When you reduce a fraction, though, you lose the original identity of how many parts make up the whole. For example, consider the 8-slice pizza. If we eat 4 slices, we have 4/8. The denominator tells us it was an 8-slice pie. If we reduce this fraction to 1/2, we lose the identity, or we lose the amount of how many parts make up the whole. 1/2 could have been in a 6-slice pie, 3/6, and it would be a 6-slice pie. Here we have an 8-slice pie. We lose that value. Unlike decimals, fractions are accurate and eliminate rounding errors. Fractions are easier to use than decimals. Which to you is easier? 0.75 times 0.83333, like 10 threes here, equals 0.625, or 3/4, which is 0.75, times 5/6, which is 0.83333, so on and so forth, equals 15/24. If I reduce this, it comes out to 5/8. If I divide 8 into 5, I get 0.625. I know what you're going to do up here. You're going to say, well, that's too many digits to multiply, so I'm just going to round off to 0.83. If you do that, you will not get 0.625. You will get some other value because you have a rounding error. You do not get rounding errors with fractions. Which is easier? 0.75 plus 0.8333, 10 threes here, equals 1.58, 3 with a line over it. Or 3/4 plus 5/6, which calculates to 19 over 12. If I divide 12 into 19, I get the 1.5888. To me, it is much easier to write 19 over 12 than all these decimal numbers. When I went to school, we were taught to stay into fractions until the very end because they're accurate without rounding errors. They're easier to use, and then only at the end convert it to a decimal. click on the link below to take an online quiz before you move on to Module 2. And this completes this module. We'll be moving on to Module 2.